The AI was the easy part. For a project with an international fashion retailer, it took me 5 days to develop the AI solution, but 10 weeks to make sure that the operational teams use it. This anecdote is a very great introduction to the job of forward deployed engineer, which is currently very trendy. Many companies are looking for FDEs with probably the highest package that you can get in AI and analytics for supply chain. So in this video, I will try to introduce you the definition of the forward deployed engineer, where the trend is coming from, why now companies need forward deployed engineers, and then we will more dig into the type of skills and challenges faced by FDEs. For that, I will use an actual project on an implementation of an AI project for an international distribution chain. I will share with you the challenges that I faced and the type of skills that I needed to make sure that the product that I deployed was used by the teams. And in the end, I will share with you a kind of study plan to improve your operational skills, knowledge, so you can meet the expectations of companies that want to deploy complex optimization or AI solutions in the environment of supply chain and international logistics. I started my career in supply chain in 2016, and at that time I was supply chain solution manager. So I was in the transportation and warehousing operations, designing solutions for retailers, e-commerce companies. So I was not working in analytics. But at that time, the trend was called big data. And then we started to hear about data science. And data scientists quickly became the sexiest job of the century, as explained here by the Harvard Business Review. This article was published October 2012. And at that time, so companies discovered AI, not the generative AI that we have currently, but what we called in the past machine learning or deep learning. And the idea was to find patterns in data, to predict information, to classify items. And every company wanted to exploit this source of data to improve their productivity, their sales, reduce the cost, improve the margin. And for that, they needed data scientists. And now, a couple of years later, we hear about forward deployed engineer. But actually, this position is not new. It comes from the company Palantir that builds solutions for governments and international firms to use their data for automation of decision-making, to understand business processes and find optimization levers inside large companies. And the idea of this position from Palantir is to say that they have a very nice SaaS tool that requires a lot of configuration, settings, adaptation to the environment of their customers. So instead of remotely connecting that to their systems, they send very smart engineers that have technical skills inside the companies to understand the processes and find the way to wire their tool to the systems of the customer. So the formal definition of a forward deployed engineer is an engineer that embeds himself inside a company's operation to make AI model or optimization algorithm actually work in their messy reality. So if you are a supply chain professional, being embedded inside a company is not new. I mean, if you need to redesign the distribution network of a company, you need to understand the flows coming from the different factories, upstream flows. You need to understand how the stores are ordering. But for these AI and optimization tools, like SaaS companies, they are discovering that it's not as easy as just plugging a tool inside the system. Each company has their own complexity. And before being able to exploit data, you need to understand how processes are generating and using this data. So this is where probably as a supply chain professional, we have an edge, because our operational expertise is the basic need to be able to deploy these complex solutions. So to illustrate that and to show you what kind of skills you can use or you should develop to become forward deployed engineer, I will use an actual implementation that I did for an international fashion retail company that is based in Milano, in Italy. So they have a central distribution center where they store like bags, garments, accessories with a very high value, and that they sell in Asia Pacific and in the Middle East. So to sell them in all these locations, they have an international distribution chain where planners create orders for the stores. This order is transferred to the central warehouse, prepared there, and then sent to Milano airport for air freight to different countries. And then they arrive in the local airports. For instance, here I took the example of Shanghai. And then after custom clearance, they are delivered to the store. So this is a complex international chain, and you have a lot of systems that are involved. So you have the WMS that is managing the data and the processes inside the warehouse. You have a planning system that sends the order to the ERP, then to the WMS. And you have the transportation management system that is tracking the shipments from the store to the end delivery. And the issue that the logistic director was facing is that more than 35% of their late deliveries are not explained. So what happened is that they have a team of planners that are manually crunching data coming from the different tables of the TMS and the WMS to generate reports. So they look at specific orders that were delivered late, and they check if the warehouse was late, if there was issue at the pickup, if the flight took more time than expected, if there was issue in the custom clearance. And they do that manually on a constant basis. And due to the complexity and the large volume of orders, they don't have the time to do complete analysis. So when the stores are complaining about late deliveries, what happened is that each team is blaming the other. The warehouse say, we received the order not on time, it's due to IT. The transportation team said, we sent the truck, but the pallets were not ready, so we had to wait. Then the air freight is saying that the shipment missed the flight because the truck didn't arrive on time. So it's highly, highly complex. And these planners that are spending a lot of time crunching data, they don't spend time on doing actual root cause analysis and, more importantly, building action plans. So the idea was to hire a kind of AI performance copilot. And here, what I proposed is to use Claude. So Claude, at that time it was 4.6, Opus 4.6, can connect to transactional data coming from their systems, TMS and WMS. And if you teach Claude how the distribution chain is working and how the data is generating with the definitions for each field, it can answer very complex questions and build all these reports that the planners are doing. And for that, you just need to connect Claude via MCP implementation to a data set that collects data from the different systems. So when deployed, the tool looks like this. So before, the planners were manually crunching data using Excel, or sometimes they use Power BI. They ask IT to perform some queries from the systems, and then they manually crunch the data. Now, they just open Claude AI desktop version that is equipped with multiple tools, and they can ask questions in plain English. So for instance, here, one of the planners wanted to know if for specific scope of shipments, the delays were due to the last mile delivery, so from the airport of arrival to the store, or due to the air freight. And what Claude is doing is calling all the different tools. The tools will help him to retrieve data, and then based on the data, answer the question. Then your planner can follow up on this, like you would do with another planner or an analyst. And in the end, you can even ask Claude to generate a nice report with executive summary, interactive visuals, multiple pages. And they do that only using plain English instructions in Claude. With Cowork, they also trigger recurring reports that are automatically sent by email. So like 90% of the manual labor for this task is done now by Claude, and planners can now focus on the root cause analysis, building action plans, organizing the performance management, pushing the teams to improve their performance. Everything powered by data, thanks to Claude. So now we know what is the final result. Let me show you all the challenges that I faced to arrive at that result. So as a forward deployed engineer, what is your role? So on the left, you have all the different systems. Here, in that case, the tables of each system was in Snowflake. So, I mean, 60% of the job was already done. The problem is that the table were not harmonized and you didn't have this single table that will take all the information needed. So what I did is I had to connect via API, MCP implementation to generate like a data set that is harmonized. And for that, I needed to connect with the different teams to make sure that the fields that are there are the right one. And then I can connect with AI to build a workflow that is parallel to the workflow that is currently used, where planners extract data from the systems or ask the IT teams to extract data from the system that is manually crunched using Excel. So here, AI was really the easy part. I mean, building the MCP implementation, building tools to query the data by giving I would say, the operational definitions of each field was the easy part. The hardest was to get this harmonized data set, understanding what is behind the data in each system. So you have to connect data without any documentation. You need to go to the teams to agree on specific definitions, and you need to earn the trust of users so they will stop their current workflow, manual workflow using Excel, and rely on the AI. So this will be all the challenges that I will share with you, and that requires specific skills that companies are looking for. So, as I told you, the Claude is connected to an harmonized table with all the information. So you have from the order creation to the final delivery, you have the timestamps of each step that is important. So for instance, here's the transmission time. So from the order creation, when the order is received in the warehouse, because if the order is not received, the warehouse cannot prepare. Then you have the start of preparation. So when the operators start to pick the products, end of the preparation, the loading time, and then all the different legs from the warehouse to the store delivery. You have timestamps and you have flags. So the flags will be true if for this specific step, the shipment was on time, and false no. And in the end, the most important flag is if we delivered the store on time. And the idea here is that with all these flags and timestamps, explain if there is like a late delivery, why. So the first challenge that I faced is can be illustrated by this table. So what I wanted to have is the creation time, when the order is created. And I asked the IT infrastructure team to say where I can get the creation time, and they gave me this table. So with these fields, that means nothing if you don't have the context, where you have two different fields with two different timestamps, and you basically don't know which one to take. So what I did at that time is a reflex from a previous project. If nothing is documented, you need, and that's my first tip that I will share with you, you need to put the users, so the people that are using the system with the screen, and the IT infrastructure in the same table. And you need to take multiple of examples, ask the user, what do you see in the screen? And then try to match that with the different fields in the table and validate that with the infrastructure guy. So in the end, this is what I did. I did that with multiple orders, so I'm sure that I cover all the scope. And I generated this formula. For this, it took like a couple of days just for one field, just to know when the order creation time is. And this can give you like a sense of the type of work that you need to do as a forward deployed engineer. Here, it's not AI, it's just to clarify a basic operation rule from the system. Now, something a bit more complicated and more difficult, the second example, where I needed to extract the loading time. So for that, I had two sources, the WMS data, so the warehouse management system data, and the transportation management system data. So here, the loading time is really like at the conjunction between both, and I will explain you why it's that complicated. So to illustrate that, let's go to the warehouse, right? This is not the warehouse of the customer, but it's a good opportunity here to illustrate the issue that I faced. So here you have the products that are prepared. Here they are packed. And then let's imagine here, these are the docks where the products are put on pallets and then loaded in the trucks. So here, what we want to measure is the time when the products are put on the truck. And here, this is very important because this is the end of the responsibility of the warehouse, and this is the start of the responsibility of the transportation. And this specific timestamp and the flag that is associated with that is a source of a lot of conflicts between warehouse team and transportation team. So at the beginning, I asked the warehouse team how to collect this timestamp, and they gave me one definition. So they told me it's very easy. The timestamp to load, it's when we have finished to prepare the pallets and we put the pallets on the truck. So what happens is if the truck leaves late, that means it's due to the transportation. And for that, I was quite confident, but with my experience, I know that things are not always that easy in logistics. So I need to find another version. So I went to the transportation team and I told them, okay, so here is the definition that I got from the warehouse team. Do you agree on this one? And this is where that things got complicated. They told me, look, there are multiple scenarios. So some scenarios where we manage the truck. So we send the truck to the warehouse. So it picks the pallets and then the pallets leave the warehouse. For that scenario, yes, I agree on the timestamp. But there are other scenarios where the truck is sent by the freight forwarding company, so the company that is managing air freight. And on that sense, it can happen that sometimes the pallet may be ready at the warehouse, but the trucks arrive late. And then it's not our responsibility. So as you can see, things start to get complicated. It was supposed to be one field that I take from one system, and then it became a very complicated rule that I will show you. After 2 weeks of reflection, 5 workshops, here is the final result. So this formula, it's the consensus, the agreement between the warehouse team and the transportation team. So when the transportation team has to be blamed, they will be blamed. And when the warehouse team has to be blamed, they will be blamed. And the idea here is to show you all the challenges faced for a simple field, which is loading time. We didn't even start to do AI, but here it requires a lot of advanced discussions, going deep into the processes to make sure that the data used by your agentic workflow is agreed by all the users that will use your tool. And for that, you need consensus, you need operational knowledge to enter deep into the processes, translating the request of each one into a formula that will be agreed by all. So then I basically did that for all the different fields. The final deliverable was the dataset that I showed you at the beginning with all the different timestamps and flags. So now we have enough data to start building the AI. So I created the MCP implementation. I have tested on multiple cases. But unfortunately, for this kind of project, it's not like a normal software. You don't have like unit tests that you can implement. For that, you need to conduct user acceptance tests. And for this, I have my own method. What I do is I ask the planners, please take your most recurring analysis that you do on a weekly, monthly basis, the most complex one, the most time-consuming one, and try to replicate them on Claude. For me, that was the best way to understand if the tool is responding the way that they expect, and if it provides the added value that users want. And I will show you one example. So in this example, I asked the junior analyst to show me one of the recurring reports that he's preparing. So his focus is on air freight performance. He's working in the central distribution planning team. And on a weekly basis, he has to report the overall performance and then the responsibility of air freight on the late deliveries. So what he did is prepare this prompt. Here, I gave him a bit of guidance on how to structure, give a bit of context, and I asked him to make sure that the Claude is preparing one-page HTML report. Why? Because he's using Cowork, and I taught him how to trigger this workflow on a weekly basis and also ask Cowork to send that by email. And this is exactly what he did. So Claude launched 10 different comments using the tools. As you can see here, you see the outputs that were used. He gives a kind of small, like very short summary to the user and then generate a report. And the report here is very complete. So you have the executive summary, you have all the visuals that are needed to be able to validate the take that you have in the executive summary. You have even conclusions and recommendations. And this was fed by, on one hand, the MCP documentation that we have implemented, but also Claude is connected to vector database where you have all the processes, standard operating processes of the distribution planning team, examples of past reports, even sometimes the wording and the specific jargon that is used by the teams. So this report is ready to be sent to the top management. And it took, less than 30 seconds to generate. And this was the type of test that I have implemented. I will not enter into details here, but what we did is we compared the conclusions of the planner and the conclusions of Claude. We checked that the conclusions were based on correct calculations, and we also fine-tuned, calibrated the prompts to make sure that the visuals are more or less the same as the ones that are used by the planners with their manual reports. And this validated on one hand that my tool is working, but also on the other hand that the users accept to use the tool. So that's a win-win in terms of efficiency and results. So as a forward deployment engineer, what did I do? So the main goal was to connect systems, ERP, WMS, TMS, with users via AI, enabling users to get the insight they need without writing a single line of code. So the first step was to make sure that we map correctly the systems. And that's all the work that was done on clarifying the order creation time or having a consensus between the transportation and the warehouse team about the loading time. This step is extremely important because that will basically create the foundation of your tool. If everybody agrees on the formulas that you've used, you did 60-70% of the job to ensure the adoption of the tool later. So once it's done that, then you need to make sure that the tool provides the expected value to the users. So you can do some unit tests on your side, but the main test is the user acceptance test. And for me, the approach that I use is I look at the current workflow of the users and I ask them to replicate that on the tool. So they know exactly what type of analysis they do, when it's right, when it's wrong. And it's a way to combine test and I would say change management, because by testing, they will get used to the new tool and continuously incorporate it in their daily workflows. And after that, you did 60 to 80% of the job. You know that the users are satisfied. Then you can continuously calibrate the tool. Probably you will have 100% of accuracy at that time. And then it's a matter of continuous improvement. But the large part of the effort is to make sure that the tool is on the hands of the user, especially operational people that are most of the time skeptical with technology, because technology is so hard to implement in such a complex and messy environment. So then, coming back to what I said at the beginning of the video, what kind of skills do you need to develop to be able to be a good forward deployment engineer, and you take this opportunity to have a high-paying job where you can impact operations by implementing cutting-edge tools. I will show you using my Supply Science YouTube channel. So if you go on my YouTube channel here and you reorder the videos from the oldest to the newest, what you will discover is that it follows exactly the kind of learning path I would give to someone who wants to get the operational knowledge and the analytics skills to work in supply chain analytics, data science, and now as a forward deployed engineer. So at the beginning, you need to have a kind of understanding of warehousing, manufacturing operations. And here in the first videos, you have short explainers that will give you the basics of warehousing, transportation, process design, manufacturing processes. So these are key skills to be able to exchange with the operational team, understand what they do, challenge their decisions, and translate their vision, like for instance, the exercise that I gave you with the loading, into formulas. And here is key because it will be expected from you. And then you need basics of analytics. And this is exactly what you can find here, for instance, with an algorithm to optimize the pallet loading. I did the same here to optimize workflows. These are these optimization tools. Here, these are very small optimization tools that can impact specific processes. And in the end, when you are going to deploy AI or optimization solutions, there will be the complex version of what is done here. And for these explainers, I share the example, case studies, context, and the technical solutions with the code. So then you can use this opportunity using the code that you can find on my GitHub to practice on the basic optimization, machine learning, statistical forecast that can be used for the operations. So these are all these explainers. I did that for nearly like 2 or 3 years. Then I moved to more longer tutorials. Here, this video is very good because it will give you all the definitions related to supply chain analytics with all the case studies that you can use to practice. For each case study, you will have a long article, a video, and a source code. And then I share more detailed case studies. So for instance, a supply chain control tower. This video is really good because it gives you the context of the tool that I have shared on this video. And here, supply chain optimization, which is more at the network design process level, for using optimization tools. And many other supply chain analytics examples. Then what you need to be able to practice, to master, is how to deploy applications. So all this, I would say, DevOps part. And this is what I tackle in a tutorial like this, where I take you from a normal inventory management module to an app deployed using Streamlit. And that will give you the initial sense on what it takes to deploy an algorithm or an AI in an environment so users can use it on a web application or via API or using MCP, using Claude or any other AI via MCP like I showed in this example. And that's roughly what will give you a kind of base in terms of knowledge. If you want to test your skills, I have also an app for that. So you go on supply-science.com and then you will arrive at that screen. In this app, you can sign in. So here I'm signing as Samir, and I will zoom a bit. You have some questions to test your knowledge. So here's a fundamental quiz that I give to some of my students to check if they know the basic concepts of supply chain. And then you have more deep dive. And for instance, here's about AI workflow automation. And all of this knowledge is coming from my blog and YouTube channel. And you have lessons. So for instance, here on performance management, what is a supply chain control tower? So you have the video that I showed you on my YouTube channel. And you can also use the quiz to validate if you understood the right concepts. So that will give you, as a forward deployment engineer for supply chain, the basic knowledge to be able to interact and bring value in a very complex and messy operational environment. If you have any question, feel free to use the comment section. Let me know if you are looking for a position as a forward deployment engineer and the type of questions that you want to prepare for the interview. I will try my best to answer, and see you for the next tutorial.